But some of you need to start memorizing like 3 weeks ago. Just kidding. Now, okay? I want you guys to go ahead and grab out a highlighter. Grab out a highlighter. If you have not yet highlighted this box of identities, you need to memorize all of these formulas, but there's more, okay? You need to memorize all of these formulas, but there's more. Now, I'm not saying all of the formulas from all of Chapter 5. That's what right now is. I'm going to tell you, even before we cover all the formulas, which ones to write out, which ones to list, okay? So, Section 5.1, all of them. Section 5.4, all of them. These are the ones that we wrote down yesterday. Single page. Here we go. All of these. Highlight all of 5.4. Now here's the problem, because we haven't gotten to 5.5 yet, right? And today we're just going to be practicing 5.4, and I'm pretty sure that's going to take our whole day. But I want you guys right here under new formulas to list the following ones that you should also try to make formula cards for, get into a Quizlet. Wait, if we haven't done notes, how are we supposed to find them? Oh my goodness, you guys know how to find them, right? What if you go in your book? You could go to section 5.5 and like look for them, but guess what happens at the end of any chapter? Summaries. You can steal the formulas from right here in 5.1. You can steal the formulas from right here in 5.4. Now, you guys are in your notes writing out which formulas, right? Right here under new formulas. What other formulas do you need to write out? The double angles. Write down double angle. Double angle you need to memorize. Power reducing. I know it's going to be a little overwhelming. Hang in there. Double angle you need to memorize. Power reducing you need to memorize. I'm going here just to make a point. These ones too. These ones too. Half angle you need to memorize. Okay, now we start to get a little bit choosy. So double angle is a yes, power reducing is a yes, half angle is a yes. Now there are a lot more, but the only other ones that you need to memorize, nope, neither one. Neither one. We're done at half angles, okay? So check it out. We could have gone this whole page, but we're not. So we're just doing double angle, power reducing, and half angle formulas. For the double angle, there are 3 different variations. Bless you, bless you. Just a warning, you're going to want all 3. Real quick reminder, just as you guys are trying to think of how you need to be studying, whether you're writing it over and over, whether you're doing flashcards, whether you're doing a Quizlet, whether you're having someone like read you one side and you give them the other. Remember, on the formula portion of the test, I'm just going to have the left side, I'm going to have the title, I'm going to have the left side with an equal, and it'll be blank. Do you guys remember how we talked about that? I'm not going to be switching it up. I'm not going to be giving you that side and you give me this side. I mean, maybe that's a good thing that I should do, but I'm not. I'm going to give you a title. I'm going to give you one side. You give me the other. Now, I might not ask for every single one, but I might ask for this and this and this and that and this. Who knows? But I will give you the title. I will give you one side. You give me the other. Are we tracking? So those of you guys that need to start studying now, make your flashcards, make your Quizlet, make whatever you have successfully used to memorize facts in the past. Maybe not in math class, but in another class. And apply that to studying now. Because next week, the end of next week, somewhere around there is our test. Okay? I think Thursday is the formula portion. Because section 5.5 is the last section. I think formulas are on Thursday and problems are on Friday, if I remember right. I think formulas are on Thursday and problems are on Friday. Are we all on the same page? Any questions about which ones to study? We're okay? Okay. So let's go ahead and get back into notes. I wanted you guys to get that because some of you need to be memorizing now. And if you can get 25 out of 25, or actually there are a couple bonus, 27 out of 25 on the formula portion going into the problem portion, well, that's already better than some of your test averages normally are. Now, the problem portion might bring it down a little bit. And I'm not trying to shame those of you that are like, there's no way I'll get 100% on the memorization part. Okay, I know memorization is a weakness for some of you guys. But you should already know that from other classes. And if so, you just need to work extra hard to try to do the best you can. And maybe the problem portion will be your higher percentage. But I've already narrowed down the formulas you need to study. All of them from 5-1. All of them from 5-4. And then the double angle, power reducing, half angles, stop. Okay? Here we go. Section 5.4. We got this whole page down yesterday, right? Okay, cool. Let's go ahead and go straight to, oh, no. I was going to give you a hint about how to study. Because this is how I'm going to be recalling the formulas for myself in class, and maybe it'll help you and maybe it won't, okay? But for 5-4 formulas, I think of cosine, because the two cosine formulas. I think of cosine the following way. I think of co as being with or together. Where did that come from? Yeah, exactly. It's a prefix that means with or together. True? Go ahead and stand up. It'll just help you out. So co, with or together. Jason, you want to be a champ and just take that to the back for Lauren? Whoop. Got it. Okay, co, with or together. It's a prefix. Wait a minute. How on earth does that apply to... Yeah, the cosines are together. And what else is together? Sine. Yeah, the cosines are together, the sines are together. So I'm going to start with cosine, 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 sine, sine. So co, with or together. And I also think about the C in cosine, the sines change. Well, we wrote them down yesterday. Did you not get them yesterday?
I already have them, but if anything's that small, then we'll do those.
Anything's that small. Let's see what we can do. Any better? I turn off the other light. Is it like the lightness, do you think, or is it the size? So not any better? Not really?
It's fine.
Yeah, I got you. I'll have you hold that. Got it. They're watermelon colors. Watch it. We can get you as close as you want up here. You can adjust it. So co, with or together. C, signs change. So what am I going to think about sine? Yeah. And not with or together. I don't know how to do that one. Cosine, co's with or together, and the signs change. Sine, the signs stay the same. Silly, it's just a way of memorizing. Now, here's a crazy thing. This can actually help with tangent, just a little bit though. You still have to memorize. But question, who is tangent?
Sine over cosine.
Sine over cosine. Oh. Is it same over change? Nice. Right? If it's sine over cosine, it'll be same over change. Same over change. Now you have to memorize who goes where. I know, I'm sorry, lo siento. But it does help a little bit as far as the pluses and the minuses. And these ones, the co, with or together, might help you with co, cosine, sine versus sine, cosine, cosine, sine. Why am I telling you that? Because I kind of have these memorized. Isn't that what I did with 5-1 also?
Yeah.
I had them memorized, and what was I having you do? Turn back and look and memorize. Okay, so today, if I'm pulling something out of thin air, I'm not. It's probably coming from this box. But I'm going to try to refer to my little clues, because for a lot of kids, that does help them memorize these ones. Okay? So let's go ahead and play. Let's go ahead and play. I want you guys to grab out your calculator really quickly. Yes, these are unit circle values. Yes, you should be able to do it by hand, and I will. But if anyone in your group has a calculator, grab it out, and I want you guys to plug in, first of all, the left one and plug in the right one. And my question to you right now, before you go to your calculator, do you think they're the same?
No.
Ah, we have a little bit of both. Some say resoundingly no, and some say, wait, that makes sense. Can't you just distribute sign?
No.
Plug it in your calculator. Let's see. If they're the same, then we're good. If they're different, uh-oh. Maybe sign doesn't work like that. Use Precalc with Joe, Lauren, if you want. What happens when you plug it in? Radian mode. Radian mode. 7 pi over 6 is not a degree. Oh, either one. You can. I just figured since he had his calculator out. Matthew, what do you think? Yes or no? Same or different? Interesting. Now, you guys are plugging in your calculator, seeing whether they're the same or different. I'm going to go ahead and play with the unit circle because Matthew said maybe I could. I'm going to go ahead and change this to be, why am I doing blue? I don't know. That's weird. Okay. Getting common denominators just to see if maybe I can keep on. Oh, hey, that does work. 5 pi over 6, which is going to end up being 1/2. Did you guys get 0.5 for that guy? Nice. Shouldn't I be able to do both of these also from the unit circle? 7 pi over 6. And there's pi over 3. I'm going to have negative 1/2. Uh-oh. Did you guys get a nasty decimal when you plugged in this one? Was it negative?
Yeah.
Long story short, are they the same? What in your brains, which is good though, based on your prior math training, what in your brains made you think it was the same? The reason that you wasn't bad. Distribution. But guess what? It's a life lesson and a math lesson all in one. Don't distribute sin. I mean sign, but I mean sin. Okay, don't distribute. If you distribute, you're saying, hey, I don't know who this guy is. He's just an SIN, and I think it's times. Yay! And you're missing the meaning of sign. It's not sign times, it's sign of. Don't distribute sin. I mean sign. But do I? Don't distribute it. So here's the struggle. What do you do if this does not become a nice unit circle value? There's a formula? Now hold on, pause. Let's go ahead and see an example as to when simplifying wouldn't end in the unit circle. What if I was to do something like, oh, hold on, I have to remember. Sine, not sin, sine of, let's do 5 pi over 6. Sure. Minus pi over 4. Got it. If you were thinking about the example that we just did, you're like, oh, okay, well, I can't distribute the sin. That didn't work. Like, that didn't get me the right answer. Distributing sin on the last one didn't work. So why don't we do what Miss D did? What did I do? I got common denominators. Good. Oh. I think we have to do 12ths, right? Okay. So that's going to be 3 pi over 12. You guys agree that's 1/4? And then 10 pi over 6. Sorry, 10 pi over 12. 12. It's 5 over 6. Good. Okay. No big deal. You guys are doing great. You're doing exactly what I did in the last problem. Sweet. Unit circle, go. Unit circle only has what denominators? 6, 3, 4, 2. Does it have a 12? So it's impossible. without our calculator. But is it? Have you forgotten so quickly the formulas at the very beginning of the notes? Go look at them. Wasn't there a sign of a minus b? And the proper to expand? You don't expand sine of a minus b by doing sine of a minus sine of b. That's totally illegal. That's distributing sin, and it's something we should never do. However, what's the legal way of rewriting? And why do that? Well, because in the one we just did, when I tried to put it together, it didn't work. But 5 pi over 6 is something I can do. And pi over 4 is something I can do. This one says, okay, you like the pieces better than the combined? I can tell you how to use the pieces. It's just not what you think it is. How do you use the pieces? Using the formula. Sine. Not with or together. I don't do another cosine instead. Not together. Then I flip them. And sine, the signs stay the same. Booyah. That's the legal way. The whole distributing sin thing, not legal. Plugging it into sine of a cosine of b minus cosine of a sine of b. I should say sine of u cosine of v minus cosine of u sine of v. Totally legal. Some of you guys might have thrown this in your calculator, might have gotten a decimal. We're going to see if this works just a little bit better. But Joe, go ahead. What's up, bud?
How this formula works, I'm just curious.
In this class, going into proofs of formulas, I do when it can be quick and concise. Sadly, this one's not quick or concise. But check it out. If you go to Wolfram Alpha, remember that website I went to that one time? And if you type in the proof of the sum and difference formulas, I bet geometric explanations would come up. Does that make sense? Yeah, at least a little bit, like it's geometric. So as we come back here, didn't we just do this? Is that 1/2? Yeah. Cosine of pi over 4, square root of 2 over 2. Minus cosine of pi over 6 is the other one, negative root 3 over 2. Square root of 2 over 2. I can multiply fractions, right? Over 4. Multiply fractions. Minus and negative is plus. Root 3 times root 2 is root 6. Some of you might try to do some voodoo. The only thing we can do is push it together in your very technical terminology. That's what I think it is. Sadly, no. Because I can't simplify either of those radicals. Neither of them are perfect squares. Because it's minus a negative, since cosine in the second quadrant is negative. In my calculator, I'm doing sine of, if you guys are checking as well, sine of 7 pi over 12. Or I guess I could have done the beginning one. I was meaning to do sine of 7 pi over 12. Where did an m come from? Anyway, this is 0.9659 dot dot dot. And guess what? Square root of 2 plus square root of 6 all over 4. Is it really that much of a surprise? But without the decimals in the last example, I bet I could have convinced at least 90 to 95 to 100% of you that these two were the same. Like, oh yeah, of course, it's distribution. It's so easy, no big deal. But we went to our calculator. They were totally different. That's why we use our calculator from time to time, just to back up that we're doing things okay. That guy? Mm-hmm. That guy? Mm-hmm. For right now, Joe, it works. For right now. Square root of 2 plus square root of 6 all over 4. So guys, are these formulas important? If nothing else, we could not do this guy by hand because we don't know 7 pi over 12. But with the sum and difference formula, we can. And remember, when we did all those formulas in section 5.1, and we did all those t proofs in section 5.2, you might have been like, what's the point? Great, you just puzzles that make practice trig. That's fun. But then section 5.3 was like, oh crud, the equation is impossible to solve unless you use the skills. Same thing here. There are going to be equations impossible to solve if you don't know the sum difference formulas. Now, I'm not going to go totally through all of these. But guys, if you were supposed to be finding sine of 11 pi over 12, and whenever you see in math the word exactly, which means no decimals, why is that really sad? No calculator. Ugh. But 11 pi over 12 isn't in my unit circle.
Yeah. No.
But, well, we're not going to put in pi over 12. So you guys want to memorize a bigger unit circle. Instead, we're going to say, oh, but it breaks down to pieces that are in the unit circle. But pause. How are you guys going to keep going? If that breaks down to that, that's good, but how are you going to keep going? Use the formula. Hopefully not distribute sin. Sine, cosine. Sine stays the same. Cosine, sine. Why am I going so fast? Because I have it memorized. Joe.
Can't you use like sine of like pi over 4 and sine of like pi over 6? You get a sine of like pi over 12 thing.
I see what you're saying. Because you're trying to think creatively. That's if we were to try to put pi over 12s everywhere in our unit circle. Does that make sense? But even then, you couldn't just do a subtraction of the two signs. That would also be illegal. You'd have to use this formula anyway. Does that make sense? Yeah. Took me a second, but good. Guys, what do you think I would do at this point if I was to keep going? Who are you? Who are you? Plus, who are you? Who are you? And then squish together. So we already practiced a sine one. I'm just going to do a dot, dot, dot. You plug in, everybody. How do we plug into a cosine formula? Cosine, cosine. Why is Matthew keeping them together? Oh, because co means with or together. So you do the exact same idea, except instead of sine, cosine, it'd be cosine. Cosine. Why? Because the formula says so. Minus, because cosine, the signs change. But guess what I would still do next, the same way I would up here. Who are you? Who are you? Who are you? Who are you? And if you're wondering, wait, what is she talking about? What did we just do in the example on the page before? Who are you? Who are you? Who are you? Who are you? Squish together. Wait, oh, who didn't I do? If at any point you're good, you can go grab a seat until you get tired again. I don't mind. Tangent, is there a formula?
Yeah.
Mm-hmm. Is he a little bit weirder than the other guys?
Yeah.
Mm-hmm. So to some extent, I mean, you can check them out, but to some extent, cool kids, kind of got to memorize that when you have two different pieces, 3 pi over 4, pi over 6, and we go to plug and chug, you kind of have to memorize, well, I need a tangent of u. Sine stay the same, sine over cosine. I need a tangent of v over 1 minus, signs change. Yeah, tangent of u. Yeah, it is minus, but then it's times. But that's getting to know the formula. You know what I mean? That's getting to know the formula. But guess what I'm going to do? Yeah. However, I'm actually going to show this one. Even though it's the same idea of like, who are you? Who are you? Who are you? Who are you? Even though it's the same idea, fractions. Have we talked about how you guys don't like fractions sometimes?
Yeah.
Okay. So I'm using, in case you need to figure out, I thought I had a marker, but I don't. I'm using the line in the cheater chart That says square root of 3 over 3, 1 square root of 3. To get my tangents, tangent starts at 1, 2, 3, 3, 2, 1. So 0 over anything is 0, and then anything over 0 is undefined. There we go. I have my 0, my pi over 6, my pi over 4, my pi over 3. So when I'm doing in my head, square root of 3 over 3, 1 square root of 3, I'm saying like, you're the pi over 6, you're the pi over 4, you're the pi over 3. Okay, so tangent of 3 pi over 4, second quadrant, tangent's negative. And over 4, 1. Pi over 6, first quadrant, positive, square root of 3 over 3. 1 minus, oh wait, we already found you. Steal him. We already found him. Okay. Even though we reviewed the unit circle, and even though this might have been a jump for you, here to here, just the formula, here to here, just a unit circle. The multiple choice answer on a test wouldn't look all messy like that. That's imprecise. That's nasty and unsimplified. What would they do? Huh? We could multiply the bottom, right? Negative times a negative, and 1 times anything is itself. Just a few of you were like, oh, it's so close. I'm just going to cross it all out and say, Some of you were like, I can flip things? But is it all over a denominator? Does anybody remember my really cool from Uganda trick about simplifying complex fractions? Can multiply by the stuck guy. What happens when you distribute 3 times negative 1? What happens when you distribute, wait, there's a plus. Don't. Just a root 3 is left. What happens when you distribute a 3 times 1? Plus root 3. Didn't have to do any like crazy denominators or anything, and I'm done. But they're so close. Don't you dare reduce. They're not the same. Stop and stop and stop. Dun, 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 dun. What was this? Just figuring out how to plug into the formulas. So what's the rest of homework? Well, we just did one of those. Wait. If they're starting with this, go peek at your formulas. Do you think maybe the formulas don't just work going forwards, but also could work going backwards? Tangent of same over change. Oh, it's a minus. Why would we? Because remember that problem we just had, we didn't stay here. We had to go to there because remember this wasn't a unit circle when we put it together. But what's true about this guy?
2 pi over 3.
4 pi over 6 is 2 pi over 3. Is that unit circle? Well, forget all that work. That's dumb. Just do him. If it is unit circle, well, your life just got a lot better, and that just got a whole lot nicer. Square root of 3 over 3, 1 square root of 3. It's a pi over 3 in the second quadrant. Negative root 3. So knowing the formulas can actually sometimes make a really nasty who knows what into something a whole lot easier. It's a unit circle. So that's not a unit circle value. We would have had to do it the long way if those hadn't combined to be unit circle. Okay, so that's kind of cool. Formulas go forwards or backwards and sometimes save us time. Sometimes make the impossible possible, an over 12. Sometimes save us time. They give us something nasty and a formula would make it so much easier. Huh. They didn't give us a U. They didn't give us a V. We have no idea who the angles are unless we do some weird sine inverse, and they're telling me not to use my calculator? Well, there is a formula, Joe. I agree. Guys, with or?
With.
Together, right? With or together. So what's the formula?
Cosine of U times cosine sine of v plus,
Y plus, Joe?
this is cosine u switch it.
Good, change.
Sine of u times sine of v.
The sines are with or together, the cosines are with or together, and the signs are changing. Okay, cool. Wait, but I don't... Oh, hold on. Look up. Look up, kiddos, look up. What do you get? Ooh, life lesson in that one. But look up. Don't we have a substitution we should make? Don't we have? Now some of you are starting to get sad though, because this is working real good for which people? Only half of them. I still need cosine of u, even though I have cosine of v. Now, here's something really important. Cosine of v comes out, all of him, and his fraction comes in. I'm warning you of something that people tend to get confused a lot. Cosine of v comes out, negative 3/5 comes in. What's going to happen to sine of u? Comes out, and what goes in? To his place, 5/13. Question, anybody that plays a sport? If someone comes to sub for you, is half of you allowed to stay in while that person goes in? No, you're out there in. It's a substitution. It's a trade. Oh, it's a V, right, Tyler? Thanks. So sine u out, 5/13 in. But we're stuck. Although Matthew up here has been saying something for a little while. And a few others are starting to say it. Triangles. Why triangles? Couldn't I make a U triangle and a V triangle and say, hey, I know some stuff about you. Anyway, I know opposite and hypotenuse about you. What could we do to find adjacent? Why do you need adjacent? Because cosine needs the adjacent over the hypotenuse. Guess what? We already know for u, because of looking at the other u, we know that 13 is a guy. We just don't know the adjacent. If we can find the adjacent, we're golden. Cosine's out, his ratio's in. So what's 169 minus 25? C squared minus b squared is 144, and 144 square rooted is 12. Could you have done that with Pythagorean? Hopefully the answer is yes. Haha! Guess what? We actually know him after all by looking at u's triangle. Given the clue about you. But who else do I need? Okay, pause. But what do you know about v? Don't we already know the hypotenuse if we look at somebody else? No, don't look at you. Got to look at v, right? Cosine of v has a hypotenuse of 5. I already know it's going to be a 5. But maybe I should come over here and then write a little triangle. And then, well, if cosine's negative, different quadrant, what would sine be? Joe is bringing up an excellent point. He's saying it could be in the third quadrant, and he's not wrong. He's right. But when you get to the examples, Joe, they're going to give you more detail than I did. I actually just gave you the beginning. And they're going to say, only look in these quadrants so you'll know which one to choose, okay? So for this one, technically, we could say something to do with u and v are between 0 and pi. So that's keeping me from going to the third quadrant. Some of you already figured out, Matthew, you're saying it, right? It's going to be a 4 for my V triangle. Cool. Let's go plug in 4. All the sines and cosines are actually been substituted for. They are sitting on the bench. Who's in? All their fractions. At which point, all I have to do is a quick little negative 36 over, I think it's 65, plus 20 over 65. And that's pretty convenient that they're all over 65, because then don't I have to do Medicare? Anyway, one subtraction and I'm done. Jason. Yes, you need. I could color code if that helps at all. I can make this guy about my V. I had to go look at my V clue. So I had V to set up my V triangle. So when I was missing pieces, I was like, hey, what triangle are you from? Oh, you're going to be from this triangle, adjacent hypotenuse. Ha-ha, opposite. Got it. My U triangle. What do I know about U? Oh, I know U? Sweet. Let's go ahead and plug U into your U triangle. There's your adjacent. Got him, coach. Oh, there he is. And then, whew. Some of you might need to watch this a little bit more and digest it a little bit more. But Tyler, go ahead, question before we move on. Oh, I got to the triangle just because trig ratios, sines and cosines, come from triangles. So when I saw this trig ratio, and when I saw I wanted something from the V triangle, for instance, that wasn't cosine, I was like, well, I know cosine. I plugged him in, but now I need sine. Well, the only way for me to get sine is SOHCAHTOA. Because I had one ratio, I said, wait, if I plug in one ratio, oh, sorry, that's a U, isn't it? Let's go to the green. Okay, we need cosine of U. We have sine of U. I was like, this fraction has meaning. It means opposite over hypotenuse. So if I put an opposite, if I put a hypotenuse, I can always solve for the third side of a right triangle. And that's the missing piece I needed to get the fraction I wanted. Does that make sense? So it's more of like something to study. You might actually want to, in a color pen or highlighter, write a note that whenever you are asked for a trig function given clues of ratios, make triangles. Yeah. Whenever you're being asked for, and the rest of you guys could do this too, whenever you're being asked for some sort of trig being given ratios, you always want to make triangles out of those ratios. So I used 5 and 13 Pythagorean to make the 12 for anything to do with U, because that's what is the angle in that one. And then I used my -3/5, my adjacent over hypotenuse, used Pythagorean to finish, so I could use this for anything with a V. Yeah. Oh, no. What are the directions? What section? 5.2. T, proof. What do you think we're going to start with, the left or the right?
Left.
Thank you. Yeah, right? 0? No, no, thank you. No, thank you. No, thank you. What's the first step? Not formula, rewrite. What's the given? Show me that you're choosing, well, in this case, the right one. Choosing 0 would be the wrong one. Distribute. No. Formula. There's 2 of them. Formula. Cosines with or together, right? And the signs change. Might you run out of room? Yeah. Why don't I go to the next line and indent a little bit? Is that okay? So cosine, with or together. Sine, sine. The sign changes. Sine, not with or together. Yeah, sine, cosine, sine. And the sign changes. No, stays the same. Ah. Stays the same. Whew, that was close. Cosine pi. Who thinks that's disgusting? Yeah, so I know. It looks bad, right? And all of it's plus. There's nothing you can but wait. Isn't this unit circle? Cosine of pi? Isn't this unit circle? Sine of pi? And isn't that unit circle? And isn't that unit circle? I think we want to look at pi, and we want to look at pi over 2. Pi over 2 has the point 0, 1. Pi has the point -1, 0. Question, who are the signs? The y's, good. So sine of pi is 0. Where's that guy? Oh, you're 0. And sine of pi over 2 is 1. You're 1. Cosine is the other guy. So cosine of pi is -1. Cosine of pi over 2, oh, I wrote that wrong, didn't I? Is 0. So what does that mean? I get -1 times cosine of theta plus 0 times sine of theta plus 1 times cosine of theta plus, I wrote that weird, lo siento. What do you see now? Those are zeros, and these cancel out. I end up with negative cosine of theta plus cosine of theta. Ha ha, ha ha. Check, here we go. Not too bad, huh? But didn't you have to use your formula first? Can you do t-proofs with the new formulas? Would there have been a way to do this t-proof without the new formulas? So we're expanding your abilities. So what else on earth could possibly, oh, yeah, what section? 5.3. 5.3 problems can now be expanded too. It's all right, it's all right, it's all right. We're right here at the end. We're right here at the end. Last problem, last example of the day. The directions tell you what you're. Wouldn't it have been so nice if you could just distribute this in?
No.
Wouldn't it have been nice? Would have been wrong, but would it have been nice? Yes, because sine of x, what? But you would have been totally wrong. So what do you do instead? The formula. Sine, not with or together. And the signs stay the same. Ah, it's awful. No, it's not. Who's that guy? Unit circle. Who's that guy? Unit circle. What unit circle? I think we just talked about him, didn't we? Sine is 0. Wait, isn't 0 times anything 0? Yeah. Cosine's 1. 1 times anything is itself. Wait.
Why is 0 plus 1 equals 0? You mean no solution?
If those cancel and you get 0 equals -1 or 1 equals 0, however you do it, I guess that's an easier way. 0 plus 1 is 1. Is that ever possible?
It's not possible.
Little tricksters, they gave me an impossible problem. What if it was possible? Well, you would have done what you would have done in section 5.3 and said, oh, sine of x equals 1/2 off top of my head, maybe. That would have been a possible solution. Go to your unit circle, find your answers. But guys, what you going to see in homework?
Those.
Maybe some ones that have you playing with the unit circle, playing with the new formulas like the beginning of class. Playing with the impossible and making it possible. Maybe ones where you're going the formula backwards to make life easier. Maybe triangles. Maybe t-proofs, maybe equations. You're doing 5.1, 5.2, 5.3 with formulas from 5.4. Yeah? All right, have it fully attempted by Tuesday. Choir people, do what you can on Monday. Don't worry about it till then, for sure, for sure. And I'll see you guys later. And you have 55 seconds. Never mind. Chill. You want to chill?
Like 20 seconds.
Why in the 50 seconds? No, I think my second hand is pretty spot on. Why in the last 45 seconds of class? While you guys are chilling, just sitting there. A little overwhelmed possibly from class. Why am I going to go here? And why am I going to go here? And why am I going to go here? What are you supposed to be doing this weekend? Writing down the formulas and studying them. Why? Because of the formula portion of the test next Thursday. What do you need to do well on that? Memorize. Sound good? All right, cool kids. Happy Friday. Happy 3-day weekend. Get out of here. You can have 8 spare seconds ahead of everybody else. Stay safe.